This week's topic is earthquakes. An earthquake is the shaking of the Earth's crust, which usually occurs along plate boundaries. We can think of an earthquake as the plates going over a bump as they slide past each other. Now, there's two locations that you need to know. The first is called a focus, and that's the actual location underground where an earthquake happens. The point directly above that on Earth's surface is called the epicenter. Most earthquakes occur on plate boundaries. Not always, but you can see right here in this map that this is the location of earthquake epicenters, and they outline the tectonic plate boundaries. In order to understand earthquakes, you need to know a little bit about waves. A wave is a transfer of energy through matter. You can think of this with the example of a ball in water. You can make that ball move by moving the water. So the energy comes from you through the water and causes the ball to move. There are two main categories of waves. Compression waves can be illustrated by a slinky. If you were to compress part of a slinky and then let it go, the wave would travel from one end to the other in a straight line as the slinky compressed and stretched out, as we saw in class. The other is a transverse wave, and that is when you're moving the slinky up and down or side to side, and it's causing these ripple-style waves to move across. Of the two, compression waves are faster. When an earthquake occurs, seismic waves from an earthquake travel through the Earth in all directions, including on the surface as well as inside the Earth. There are two categories of seismic waves. There's body waves, and those are the waves that travel underground, and you can see that with the red arrows here in the diagram. And surface waves are waves that travel across Earth's surface, and you can see that in the blue line in the diagram. And the surface waves are the ones that cause all of the damage. The body waves are further broken up into P waves and S waves. P waves are fast, they are the compression waves, and they travel through solids, liquids, and gases. S waves are slow, they are transverse waves, and they can only travel through solids. You can see in the diagram here the difference between P waves and S waves. There are two kinds of surface waves, R waves, which is short for Rayleigh waves, and those are waves that go up and down. They're also transverse waves. And L waves is short for Love waves, and those are the waves that go side to side. They're also transverse waves, and these are the waves that cause the most damage in an earthquake. This person is Inge Lehmann, and she was the scientist who used earthquake data to determine what's inside the Earth. She knows that the S waves can't travel through liquid, and after an earthquake, the P waves arrived on the other side of the planet, but the S waves did not. Therefore, she determined that the Earth's core must be liquid. And here's a diagram showing that from the focus, the P waves and S waves travel out in all directions. The P waves go all the way through the Earth, including the core, but the S waves, when they hit the liquid core, they stop. And here's the same information in a more colorful diagram. Earthquakes are measured on an instrument called a seismograph. The basic way this works is that you have a pencil that's suspended and a piece of paper that is constantly moving, and then if the Earth were to shake, the paper actually moves underneath the pencil, and you can measure how much the Earth was shaking. Here's an example of a seismograph. You can see that at first, going from left to right, the Earth was barely moving. Then it picked up some P wave vibrations, which are the fastest ones, then some S wave vibrations, and then finally the surface waves were to follow. In the video right after this, it's another teacher who's describing how to plot the epicenter of an earthquake using P wave and S wave data.
Let's do an example of how to locate the epicenter for an earthquake that takes place in the United States. This is a seismograph from Salt Lake City. Here's where the P wave arrived. It was 1 minute. Here's where the S wave arrived. That was at 4 minutes. So let's write that down. The arrival time for the P wave was 1 minute. The arrival time for the S wave was 4 minutes. So then the difference in arrival time for the P and the S wave is equal to 4 minutes minus 1 minute, which is equal to 3 minutes. Okay, so we know the difference in the arrival time. That's all we need to know to come to the P and the S wave chart here and to find out how far away the epicenter was. So I measure out 3 minutes over here on the scale for time. See that? Now I slide along the P and the S wave chart until I find exactly where 3 minutes fits. Right there, you see that? Now I drop a line straight down that little dotted line, and I found it. I put a little box around it. That's 1,800 kilometers. Therefore, we now know the city is 1,800 kilometers away from the epicenter. So I go to my map right here. Now if you look right up here at the top of the map, there's a scale, and I'm going to measure out 1,800 kilometers. You see that? It's right there on the scale. Okay, that measures 1,800 kilometers. Now I'm going to take that line and I'm going to bring it down here to where Salt Lake City is. Okay, just done that. See that line? That's 1,800 kilometers. I've labeled it. Now if I were to draw a circle around Salt Lake City that's exactly 1,800 kilometers in radius, like I've just done there, then anywhere on that circle we could have had the earthquake. We don't know where, but anywhere on that circle we could have had it. Okay, once again, I measure out 800 kilometers up here on the scale. I measure that same distance from Houston. There's 800 kilometers. I draw the circle, and as you can see, this circle intersects in 2 spots. Now we've narrowed down how many places the earthquake could be to one of these 2 spots. Okay, now remember, when you guys do it, you're not doing it on the computer. You're going to be using a compass, and you're going to measure out the distance with the compass. You put 1 point at 0, you put 1 point at the distance. In this case, it would be 1,300 kilometers. And then you put 1 spot on the city, and you are able to draw your circle. So we measure 1,300 kilometers from Savannah. We draw our circle. And as you can see, all 3 of these circles now intersect in 1 spot. Okay, so I put a box around this spot. Now, you haven't finished until you've actually put an X where the epicenter is. So here's my X, okay, and now I'm finished. I have my 3 circles. They all intersect in a single spot. I've marked that with an X. That's where the epicenter is.